Hello and welcome to Microsoft Hates Greg. My name is Greg Deckler, and today we're going to be talking about creating your own X aggregator. So, not complaining about Fabric or Copilot. I got no complaints at all. We're just getting back to some of the roots of this channel of creating wildly inappropriate DAX stuff. In this case, how you can create your own X aggregator in DAX. What we're going to be doing that on is a question that came up in the forums around doing a bitwise OR among an unspecified or varying number of rows, essentially. All right, so I've got these up published out in the quick measure gallery with the PBX files and everything like that. So the first one was XBit OR right here, and then I also extended that to XBit and XBit OR. Back in the day, I created a bitwise OR. This is before Microsoft created their own, basically ported the Excel bit OR function over to DAX. And you can see here, it's quite involved in terms of basically what you're talking about here is you got a for loop here where I'm essentially turning a decimal number into a table of bits. Okay, and the same thing, I do that with the second decimal number. Then you go through and do your OR using another for loop, and then eventually, basically get your decimal number back. Anyway, I'm not going to go into all that, but this was back when I was doing my, I kind of got a wild hair, and and decided I was tired of seeing all the community forum posts about how do I translate this Excel function into DAX. And so I went through and decided I would try to replicate every Excel function there was in DAX. Then, of course, Microsoft came out with, added all the financial functions and a bunch of other functions from Excel into DAX. And I haven't updated this thing because updating stuff on the community site is a real pain these days. So anyway, so I've kind of been down this road before, but it was limited to just, 2 decimal inputs. Okay, so how do we create a similar thing like this, but for a varying number of rows, right? Okay, so let's bring up the Power BI PBX file. And you can see the setup for this is basically what they have is they had a customer and a month, and what they wanted to do was to take this string of just ones and zeros, right? So it represents kind of like a binary number. And I think the setup for this was basically there's 31 of these, and so it's for every day of the month, up to 31 days. Luckily, they're all 31. So I guess if it's 28, it's 28 days in February. It just gets padded to 31. I don't know how the original data for this came about or why it's formatted this way or anything else, but what they wanted to be able to do is and I'm not sure why this is sum of month. We'll just do not summarize. Doesn't really matter because these are all unique. Anyway, so here we go. Customer 2. So they wanted basically this is customer in the second month. Customer 1. They there's a 1 in the 5 column, essentially the 8 and the 14, I believe. And so then when you want to, if you do a bitwise OR on all of that, right? You get 1, 8, and then 14. This is what they were looking for, and I think that eventually they just wanted to count the ones and say that there were 3 days. Anyway, it doesn't really matter. First step is the hard step is to get to this right here. All right, so how do you do that? It's kind of similar to the bitwise OR, but it's actually, I think, it turned out a little more elegant than that. It's definitely shorter. So basically what you have to do first of all is you get the row count, right? So we have to know how many rows we're dealing with. So in this case, right, we're dealing with 3 rows. You then want to get the length of it. So I put in the length of the max of the bit day. And in this case, they're all 31, but whatever, in terms of, so luckily in I don't know how this would work if you had varying lengths of bits. Probably a solution, but we'll save that one for a later day. And then the next thing I do is I concatenate all of the bit strings. These are texts, right? I concatenate them all into one big string, okay? Now, normally I would use a separator here, delimiter of the pipe characters, so I could then, as Brian Julius always says, abuse the path functions to pluck out, my text strings. But in this case, since they're all just one character for each position, I don't have to do that. So I can just concatenate them into one big string. Okay, so then we get to our first for loop, right? So the for loop starts with this generate series, and I decide to go with a 0 index here. And then I have to, so I'm trying to turn that big long string into a table, okay? So the number of rows in that table is going to be the row count times the length. And then since it's a 0-based index, then I'm going to subtract 1. Okay, so then I have to grab my bit, right? So I can do that using the mid function. So I can say the mid of the string, that's my concatenated string. I say the value, which is, that's what's returned by generate series. That's kind of like my index, right? Plus 1, because it's 0-based, and the first character in a string is 1, not 0. And I'm grabbing one character, right? Now I'm adding 0 here just to make sure that it becomes a number and doesn't, so I don't get into trouble later on trying to, and like, oh, you can't compare text to number, blah, whatever. So they all become numbers in the table. And then and then I create this mod right here, which is the mod of the value, and then the divisor is the length. Okay, so what I'm doing there is it's actually creating a kind of like a repeating index. So what's going to happen? Well, I'll just show you. It'll be a lot easier to explain. To CSV table. I'll comment that back out. Oh, I need one other thing. So I'm going to need to show at least 30 some of these records. We'll just say 50. Okay, so if we go back over here, you can see here's my value. Here's my index, right? 0, 1, 2, 3, 4. So this is counting what position it is in the string. There's the bit for that position, right? So in this case, it's grabbing this guy right here. This guy sits in the 8 position. So it's 7 because it's 0-based, and it's 1. And then my mod, so you can see here, it starts at 0, 1, 2, 3, 4, and it goes all the way up to 30, and then 31, it starts repeating, okay, back to 0. Right, and then, yes, 30, because I thought I found a bug, but no, it's 0-based index, so the 30th one is actually the 31st character, so it gets to 30, then once it rolls over to the 32nd character, which is 31 as far as the index, because 0-based, then it starts back at 0, right? And then 1, 2, 3, 4, 5, 6. And that way, right, because these become the positions that I want to compare. I want to compare all the zeros, right? And then do a bitwise OR between them. And same thing I want to do all of the first character, all the second characters, right? All the third, all the fourth, etc., and all down the line. Okay, so this is what's going to allow me to do that. All right, let's go back to this. Get rid of that. And let's keep taking a look at this. All right, so now I start with my second for loop, right? So in this case, I'm going to do a 0-based index. So this for loop is going to go from 0 until the length of the string minus 1. So it's going to do 31 iterations in this case, right? Starting at 0, okay? So I add my bit OR column, and all I have to do is I grab my index, right? So that was that 0, 1, 2, 3, 4, the value that was generated by this guy, right? And then what I can do is I can just do a sum x across and filter the table, it's this table, where the mod is equal to the index, right? And then I'm summing all of the bits together, which is why I converted this to a number. All right, so now in an OR operation, right, if the sum is equal to 0, then none of those bits were 1, right? So I can return 0. And if any of those bits are 1, or if, even if 2 rows are 1 in an OR, then I can return 1. And that gives me my result back, so my bit OR. Then all I have to do is concatenate all of that together. And that gives me, oh, back here. Now, importantly, right, I have to sort it by value in ascending order. So that'll sort it from 0 to 30, right? And now it'll be in the correct order. If you don't do that, who knows what order it's going to come back in. So that's how this string gets built, right? And so some of the other ones they're exactly the same code, right? But in the and case, right, all I have to do is compare for this if statement. If the sum is equal to the length, or the row count, I should say, then that means that all of the bits were 1, right? If it's equal to that, so I can return 1. Otherwise, I return 0. And in the case of a sum x, or bit x or right, exclusive OR, right? I just have to check to see if the sum is 1 and then return 1, otherwise return 0, right? So that's the only difference between the other ones. So that in a nutshell is kind of how you can create your own X aggregator. In this case, using bits, or the bit functions, bit or, bit and, bit XOR, and that sort of thing. So that is really all I had for this video. We're trying something out new. I'm on a different screen this time, so if I look like I'm looking up or something like that, I'm just trying to get my eyes not to be so squinty in these videos. So anyway, that's all I had for this video. Hope you enjoyed it, and I'll see you next time.